All right, everyone. Hi. Nice to see you on the first seminar on the third season of Spatial Warsaw Research Group. We today have amazingly interesting paper by Andrzej Toroy and Julia Kotowska, and we have luckily both authors here as the guests. So Julia will be the presenter, and Andrzej, just in case if you have any questions about the paper or something, you may ask. So thank you for accepting the invitation. We're happy to host you today. So please start. Floor is yours. Good luck.
Thank you. Hello. At first, I would like to thank you for this opportunity to share with you the results of our work. And I'm really sorry I couldn't be there in person, but I'm currently at work, so I just took a quick break now to present our study. Without any further ado, let's begin with the motivation behind our research on the impact of regional airports on the regional development in Poland. Air transport is one of the fastest growing industries. And according to the 2019 report of the International Civil Aviation Organization, the volume of air transport has doubled every 15 years. And the EU, the growth of a number of new airports has accelerated in the recent years as well. And basically, this phenomenon is in line with the growing demand for air services. And because of that, traditional airports are reaching capacity limits. And all these factors taken together has given a rise to the development of regional airports. In addition to the fact that regional ports are an important component of the transport network, decisions related to their location can have important consequences from the perspective of the development of local economies. So regional airports can be perceived as so-called instruments of territorial cohesion policies, with the rank of a, let's say, strategic tool for attracting business and stimulating economic growth at both national and regional levels. According to the literature, those employed in service sector travel more than those employed in other sectors. So the presence of an airport can therefore be a key factor in companies' decision to locate in a region, which enables and encourages direct interactions between workers and companies, or between different areas of the economy. So in our study, we opted for econometric analysis to validate the view that airports stimulate the development of local economies. And to prepare for the study, we have referred to the literature concerning the impact of airports. And at first, we searched for the impact of broadly understood infrastructure. So we found a vast body of literature on transportation having a positive impact on widely considered growth, which kind of reinforced our belief that transportation is an effective instrument of regional development policy. However, we also found out that some research results turned out to be insignificant or even negative, suggesting that sometimes the impact may not be as intended. And with regard to the aviation industry itself, the body of work is rather limited. We learned about different measures that try to capture the contribution that the aviation industry has to the economies. And to approximate the level of air connectivity of a region, researchers often use information on the number of passengers or aircraft loading or the number of flights taken. But such measures may not fully capture the potential importance of an airport activity in generating economic benefits, which is why, as you can see on the third point, some analysts in more recent studies have opted for an alternative approach, such as air connectivity or airspace access indexes. When it comes to binary variables as indicators of airport presence are relatively rarely used in the literature. Only few studies have looked at the moment of opening new airports, and I think we listed on the slide, we listed all of them that already exist in the literature. And when it comes to spillover effects, only a few authors refer in their works to spatial effects generated by basically different types of infrastructure. So the conducted literature review provided us information on the measures used to best approximate the impact of an airport and which demographic or economic variables might potentially be affected. And this was crucial in selecting the appropriate research method and variables for our analysis. So we therefore opted for econometric analysis using a difference in differences approach. This is a well-established tool for assessing the impact of a policy treatment, which in our case we considered to be the establishment of an airport in a given location. And our analysis focused on 3 out of 6 regional airports built since 2001 in Poland, and specifically those airports established in regions that never had a local airport before. And when it comes to the dependent variable, which should reflect the development of the region, we saw that researchers basically mainly focus on the following variables: population, GDP, and employment, with the latter two potentially taking the forms of per capita or sector-specific, respectively. And well, obviously, GDP seems to be the best candidate for a variable reflecting the development of the region. However, as indicated by researchers who have studied this variable, it is almost certainly associated with the problem of endogeneity. And having that in mind and following measures of other scholars, we have decided to use regional employment as a proxy of regions' development, but we specified the local employment to be sector-specific, namely service-oriented, because as I already mentioned in the beginning, the air connectivity is the most important to service sector workers. So that is why we chose such a measure. And we considered the service employment as a share of total employment in the region, since this allowed for relative comparisons across time and regions. We estimated 2 models to explain the regional employment. So first, we used the difference in differences method and an alternative estimator of average group time interaction effects created by researchers Calway and Santana, and to find the impact of an airport in a given region on the share of employment in services in neighboring regions, we estimated spatially lagged version of the difference in differences estimator. So in our analysis, we considered 3 airports. The first one was Modlin Airport, which is located in Nowy Dwór Mazowiecki. This is about 35 kilometers from Warsaw, and it was built on the basis of a military airport that existed there until 2000, until year 2000. And the estimated capacity of this airport is about 3.5 million people per year. The second one was Lublin Airport, which is located in the city of Świdnik. This is about 10 kilometers from Lublin. And the airport's capacity is set at about 1 million people per year. And the third one is Radom Airport, which is located about 4 kilometers from the city center. And this airport is actually a specific case, since after only 4 years of operating, it filed for bankruptcy. So it was closed in 2019 and reopened in 2023. Out of all counties in Poland, we formed a group of free treated units and control units. So the control group was formed by counties that minimized the Euclidean distance to the treated counties in terms of 3 socioeconomic variables. So we chose GDP per capita, population, and our output variable from the pre-treatment period, which was once again share of employment in services in total employment of the region. And to each treated county, we matched top 3 counties that minimized the distance and had no airports, were not adjacent to the treated counties, and belonged to the same class of counties, which is either land or city counties. So this last point brings us to the question of the sample composition. And as you can see, we created 4 samples. So the first one is the base one. And here, the treated group consists of 3 counties hosting the regional airports without giving any additional consideration to the type of the county or its history after opening. And these counties are Nowodworski, Radom City, and Świdnicki. The sample also involved top 3 matched counties per treated unit as a control group, and in spatial regressions, the neighbor counties that shared a common border with the treated. In the second sample, we included land counties only. So this was created because 2 out of 3 considered airports were located in land counties, but the third one, Radom, was located in the vicinity of the border between a land and a city county. So we therefore excluded city counties from the analysis, and this basically meant that that we used Radomski County instead of city Radom in the treated sample, with an appropriate adjustment of the control group and neighbor list. And the third sample considered merged counties. And this one was created because, well, both Świdnik and Radom airports are situated in a direct vicinity of a border between counties. And in both situations, this is a border between counties of 2 types. So the city county, which in case of Świdnik airport was city Lublin, and in case of Radom airport was city Radom, and the land county, which was Świdnicki and Radomski, respectively. And obviously, both groups, that is city and land counties, differ fundamentally in terms of spatial and economic characteristics. Hence, we decided to cluster two involved counties, that is city plus land, and considered it as a treated unit in each of the two cases. And Nowodworski County was left unchanged. So in such a setup, the control group consisted of the matched units for all five counties that entered the treated group. So in all, we had 15 control units. And the fourth sample in which we excluded Radom, and this was made because while the two airports established in 2012 have been functioning afterwards without any further difficulties, Radom did not. So this suggested that the group is probably heterogeneous, and in this variant, as compared to the baseline, the Radom airport was basically excluded from the analysis. So there were only two units in treated group, and the control and neighbor groups were downsized accordingly. So firstly, we applied difference in differences method, which is widely known approach for studying policy impacts. However, in most cases, we have to deal with more than two groups and two periods, so the before and after treatment period, as it is in a canonical setup of the model. Because basically factors of influence usually appear at different periods. So the two-way fixed effects version of difference in differences method became a commonly used one to study units that are treated in different periods. And as you already saw, this was our case because we had two airports established in 2012 and one in 2014. So the two-way fixed effects is particularly helpful in isolating the effect of the event from other confounding factors, because the key feature of such model is the possibility for controlling unobserved heterogeneity. So as you can see on the slide, we had the outcome variable, which once again was the share of employment in services in total employment of the region. We included the dummy variable, which indicated treated units in treatment periods. So the variable took the value of 1 only for the treated counties since the period in which they experienced an establishment and later functioning of an airport. And we also had individual and time effects. And as a robustness check, we considered an alternative specification in which we avoided the estimation of a full set of individual and period effects, but instead we used additional regressors with pre-treatment values so that they do not violate the parallel trend assumption. So on the side of time effects, we considered two dummies, indicative of periods post-2012 and post-2014. And on the side of individual effects, we included three proxies. So the logarithm of mean wage in the region, the balance of migration, and length of roads with hardened surface per 100 square kilometers, which we basically called road index. And all of these values come from the pre-treatment period year 2008. And then to estimate the treatment effect on neighbors of the treated, we used the concept of spatial difference in differences regression, including SLX type term of spatially lagged treatment indicator. So here W of course is the spatial weight metrics reflecting the neighborhood connections. And here in this setup, we also considered alternative specification with control variables. And as I already mentioned, when treatment timing is heterogeneous, the two-way fixed effects version of the model is usually used. But in such cases, it wasn't so clear for the scholars how the comparisons of treated versus not treated units were made. And this was until the scholar Andrew Goodman Bacon decomposed the two-way fixed effects difference in difference estimator, showing that it combined various comparison effects. So on the top of the conventional comparison between the treated and the control group, it also involved the contribution of the comparison between the later treated and the earlier treated units that at some point of time join or quit the control group. So basically, the problem could be that observations included in the experiment earlier serve as a control group for observations included later. So here on this example on the slide, we have dual treatment timing, T1 and T2, where T2 happens after T1, and we've got a single control group U. So in the first comparison, this one is basically made between the treated and control units. The second comparison bases on the time treatment. So before time point T2, observations subjected to the treatment earlier, so the ones that received treatment at time point T1 are the treated group, while the observations subjected to the treatment later are the control group. And the period when the status of one of the groups changes, so the earlier one group, this time period, this time window, let's say, is called mid here on the slide. And this is compared with the pre-experimental period. And in the third case, at time point T2, the status of the later group changes, while the status of the earlier group doesn't, because these units are already included in the experiment. They are already treated. So in this situation, observations under the later treatment are the treated units, while those that were already included constitute the control group to those units. So the period after time point T2 is compared with the period of status change, again, the window, the time window called mid. And eventually, the estimate of average treatment effect on treated is composed of all these various comparisons. So this small s, you see here that I highlighted with arrows, represent weights that are computed as a function of the subsample size, relative sizes of the treated and control groups, and the treatment timing. So basically, as you can see from these equations, and later you will see in our example, such decomposition is particularly helpful in displaying heterogeneity in the components of this weighted average, and in determining the comparison group that matter most to the average. So the potential problem with two-way fixed effects, difference in differences estimator, is that it equals the average treatment on the treated estimator if the treatment effect is, first of all, homogeneous across groups, and second of all, the parallel trends assumption holds. And in our case, we verified the latter to hold, but the former assumption is basically usually violated in practice. So, as a solution to this, scholars searched for methods that would allow for group-wise heterogeneity. And in our study, we used one of such group-wise methods, namely the estimator created by Callaway and Santana. We did it both in non-spatial and spatial version. So in short, what they did was they used average treatment effect for units who were members of a particular group at a particular time period. So in this setup, for instance, it is possible to show how average treatment effects evolve over time for the specific group. So you will see this in our results in a moment, and I think then it will be more clear to you. So in the spatial version, we applied this approach to both two specifications I showed you, so the without and with control variables. We did it separately to see the group-wise effects on the treated and on the neighbors. So we just split the previous equation into two separate. And here are the results from basic specifications. That is the ones that didn't include control variables. And in the samples 1 and 3 that included Radom City or the conglomerate of the Radom City and the ring county around it as a treated unit, for those samples, you can see that results are not statistically significant. And this is in contrast to the samples 2 and 4 that considered the ring county around Radom as a treated unit or disregarded Radom airport at all. In those cases, the average treatment effect for the treated is significant and amounted to 2.5 to 3 percentage points of share employment in services in the region. And this clearly suggested heterogeneity between the treatment effects. When it comes to spatial models that you can see on the right side of the slide, the estimated effects were lower for neighbors than the effect on the treated, but with the significance levels of 5%, these effects couldn't be considered as significant. And to see the group-wise contributions to these results and to verify the extent to which the comparisons between earlier and later treated units weighed on the results, we performed the Goodman-Bacon decomposition. You can see here in both versions, non-spatial and spatial. And so we did this for samples 1, 2, and 3. So the ones with staggered treatment timing. And as you can see, the estimated treatment effects originated from the comparison between the treated and the untreated rather than between later and earlier treated. And here you can also notice an interesting thing, that the aggregate results of samples 1 and 3 hide a considerable degree of heterogeneity. So here we have positive estimates of the group 2012, so the group of Świdnik and Modlin airports that are averaged with negative estimates of the group 2014, so the group with Radom airport. And this relatively wide range of the negative effects on Radom depends on whether we consider the wider Radom area, so the city and land county, or the city itself as the treated unit. And as regards the treatment effect on the neighbors of the treated, the 2012 group contributes a higher effect than the 2014 group. And those results are roughly confirmed by the group-wise estimator. So here we have visualized the year-by-year estimates for each group. And well, these results confirm the heterogeneity between the 2012 and 2014 group in terms of average treatment effect on treated point estimates, and also the limited impact on neighbors. There are only 3 cases of statistically significant results at the 10% level, but those apply only to the 2012 group. The results for 2014 group are always negative and not significant. So in the baseline setup, you can see here the average treatment effect on the treated estimate for 2012 group is positive and significant for non-spatial version and negative for neighbors of both groups, but not significant. Here in the second setup, where we considered land counties only, the average treatment effect estimate for 2012 group is also positive and significant for non-spatial. For neighbors of groups 2012 and 2014, positive and negative respectively, but not significant. And in the setup with merged counties, though the results for group 2012 are positive again, they are not significant. And this is also the case for the neighbors of this group. For the 2014 group, the results are negative and not significant. And in additional estimation, where we replaced individual effects with 3 control variables in the model and time effects with 2 dummies, we gained some degrees of freedom, though we decreased the fit, but it still remained quite high. So here most of the conclusions basically remained unchanged. And the conclusion. So to sum up, in our study, we considered the impact of 3 regional airports in Poland on the economic development of counties hosting them, as well on their neighbors. So that is counties that share the border with them. And as an approximation of the economic development, we used share of service employment in the total employment of the region. As an estimation method, we used two-way fixed effects difference in differences model because we had to deal with staggered treatment timing, and we developed models in both non-spatial and spatial versions. We have created 4 samples, each one consisting of different set of treated units and top matched control units, along with neighbor lists. Additionally, we took a closer look at the difference in differences estimator by decomposing it, and this confirmed the heterogeneity of our results across groups. And as you saw, depending on the specification, the results indicate the average treatment effect on the treated of 1 to 3 percentage points, but the statistical significance of this effect is basically far from robust, and it depends on the exact model specification and sample choice. And we also found no evidence of spatial spillovers. So given this reported evidence, I think it may be concluded that Polish airports might have had some moderate contribution to the economic development of the counties hosting them. But again, these findings should be interpreted with caution, basically. So, so that would be all from me. Thank you once again for having me and for listening. And I hope you enjoyed it. And thank you once again.
Thank you so much, Julia. Thank you so much, Andrzej.